Well, hello everybody. Welcome to this episode of Master the NEC's radio show where we talk about things that are interesting and unique about the National Electrical Code. So today's episode, we're going to talk a little bit, as I promised, about insulation resistance. We're going to talk about some of the myths about it, I guess, that we hear a lot. When people are out, our electricians are out in the field, and they get some wire, and they're actually going to install it in a raceway, or before it's installed in a raceway, they want to check the insulation resistance. And we're going to talk about that, and we're going to talk about some of the manufacturers that produce these type of products, the megohm meters that are supposed to, in order to detect this current that possibly could leak through insulation that is weak or poor. There's no perfect insulation, so we have to understand that. There's always going to be some sort of amount of current leakage when you impose a voltage pressure onto it, and that's what these megohm meters do. And then what you'll get is you'll get an opposing return path. Usually these meters have two leads on them, sometimes three if it's something you need a guard in order to isolate out something in the test. But realistically, we're looking at two leads, one that's applied whether it's a 500 volts DC or 1,000 volts DC. You'll apply that on it, and then what you'll get is the return path is measured through the leakage. Now, this is correct. This is how the products work. However, there's some fallacies here in this process that a lot of people today will do a lot of testing, and in some cases make quite a good living on doing testing. And then when the reality is that you can't really do the tests that you think you can do with a megohm meter or a megaohm meter, and all you got to do is kind of ask the manufacturers, Fluke, Megger, Hioki, all those, and the engineers will tell you they weren't really designed to test insulated conductor to insulated conductor, and that's typically what we do in the industry. So we're going to kind of talk about those different things and dispel some of those myths. So you're an electrician, you're learning the trade, and you're on a job site, and now they say, look, we get this reel of wire that comes to the job site, and we have a pre-inspection process where we look it over. There's no damage to it. We don't see anything there's a proper way to forklift products off and all those kind of things, right? So there's a process to all that, and so when they do that, they're looking to make sure that all that stuff is done correctly. Once it's off the job site, then what happens is, once you unload it off the supply truck or however you get it, at this point now you're actually going to do some testing if you like. Now, the manufacturer tests the wire. Okay, so take the manufacturer that I work for, example. We test all the products ahead of time, whether it's the thermoplastic, THHN, THWN-2, THW, what have you. We test that ahead of time, and actually during the production we run it through as it's the conductor, the actual wire itself, the copper or the aluminum is run down the line. Then it goes through extruders, and extruder puts the PVC material on it to the varying thickness depending on the size of the wire and depending on what standard we're dealing with. And then of course it runs it through what's called sparkers. Now the sparkers are really putting anywhere between 7,500 volts and 20,000 volts onto that insulation, into that wire at contact points for specific length based on the speed and the size of wire. And the voltage can change to induce the weakness in that insulation during the production process. That's the most optimum way to do it when you have a thermoplastic, which is a relatively thinner of the group of insulating material. So, you've got the thermoset, which is an XHHW, or a PV, which is a much thicker type of insulation. And it's tested to a UL44, so it's a little different than the UL83 for the thermoplastic. The standards allow either, so most manufacturers choose to run what's kind of continuous line, and they actually check the thermoplastic products through a sparker. Now, when it comes to the XHHW-2, the RHHs, RHW-2s, the USE-2s, the PV, all those things are more or less a cross-linked polyethylene product. They could be sparked as well, but due to the insulation thickness, it's much better to do actually a dunk tank test. So they actually take the reel of wire, and actually every reel gets dunked in a water tank. And there's a probe in the water tank, and then the leads are turned up above the water, so you lower the reel. Doesn't matter what size, whether it's a smaller one or 1,000 kc mil. It gets dunked into the tank, and then the leads are above the water because you don't want the leads to get in the water. And then you connect one end of the megometer to one of the ends of the wire, and then the other end goes to the probe that's actually down in the water. So then we apply 500 volts DC or 1,000 volts DC, depending. And I mean, both are acceptable as far as the UL standard goes. In fact, the UL standard says 500 volts DC. But again, it certainly wouldn't hurt to use 1,000 volts DC, especially in some of the thermal set products that we use. It's not going to do any problems there. So anyway, we do it, and then you take a reading. And if there is any potential current leakage that's excessive to what the standard would allow, that's where our standard gives us specific megohm readings that we're going to compare to. It's basically, it starts at the 1,000-foot length, and then we can adjust that value using a formula up or down depending on the length that we're talking about, whether it's 4,000-foot roll, 1,000-foot roll, 700-foot roll, 500-foot roll, it doesn't really matter. So we come up with these values, and in our case, they're all published right there at the test facility. And so they document every test, and if it fails the test, the minimum standard based on the UL, then that reel is rejected. So that's all done in a controlled environment. All of the conductors are encapsulated in water. As it's lowered down in, it allows 1 minute to acclimate to the water, allows it to get all up into those voids around the wire, and then we do that test. And if it passes that test, it goes on, it gets heat shrunk, and it goes out to the job. Again, none of the ends were exposed to water. It's simply the insulation, and it is a wet rated insulation. Again, if it's going to be in a raceway or it's going to be underground, it's going to be wet rated. So really, for the length of time we're exposing it, never a concern. So we do stress it out that way, and it comes to the job site. Now, once it gets to the job site, again, you have to be very careful about how you handle that wire, where you put it, where you store it. You have to keep it out of moisture, out of the rain. All these things, don't want to let any contaminants get on it. If there's some kind of pulling lubricant that's already applied, that is a contaminant when it comes to doing insulation resistant testing. So you have to keep that in mind. If you're applying any pulling lubricant on it as you pull it in the raceways and then you do some tests, you have to keep in mind that you don't want to have the ends terminated, because that's going to affect your test, because you're going to pick up some kind of position from the actual termination component. All those type of things have to be taken into account. It's simply not a matter of pulling out your megometer and start making connections and expect to get any reliable results. It's just not how it works. However, I routinely see companies all over the country, and I guess that's what I'm kind of doing here. I'm probably one of the first in the industry that's actually exposing this dirty little secret. The dirty little secret is that you cannot test insulated conductors to insulated conductors and get an accurate reading for insulation resistance. Now, in a non-metallic cable, let's take a tray cable, where all of the inner conductors, which incidentally are the same inner conductors as whether or not you were to buy individual wire on a reel, it's just cabled and put inside of a non-metallic product, then there's no real way excuse me, that you're going to check insulated conductor to insulated conductor. Now, if you do a continuity test and there's damage between two opposing conductors, then it comes back on your continuity test and there's a problem. It's been damaged somewhere in production. Now, you have to remember that these conductors, if they're thermoplastic used in this product, then they've been spark tested. They've run through multiple sparkers, and they've run at a rather high voltage level. That if there is a weakness in that insulation, a breakdown somewhere, it's going to arc out to the conductor. The machine is going to detect this and shut it down. So it's probably one of the best methods we have in order to detect this. Now, when you're dealing with the thermal set, again, we use the dunk tank, which isolates it out so that there is any potential leakage. You're going to get the best representational reading because it's going to come through the water to our probe and be able to record those results. Now, That's a perfect condition in a perfect world. Now, when you're out in the field, it's not so easy, because if I have two insulated conductors and I'm trying to hook between the two, which is routinely what's talked about in a lot of these training manuals, is they say test A to B, B to C, A to C, and then each individual conductor to ground. It even talks about isolating. If you're testing A, connect B and C also to the equipment ground, and do your testing to isolate out. Okay, that would be fine if their notion was that all of the insulation that I'm connecting to is potentially weak. And the notion that I'm sending out with 500 volts DC into a conductor, and the conductor insulation is bad or has excessive amount of current leakage, that the other conductor that's next to it is going to be equally bad, and it's going to allow the absorption of that leakage current. That is kind of a misnomer. And if you don't believe me, pick up the phone and call the engineering departments for Fluke, Megger, or Hioki. I have. Now, they might tell you differently if they're trying to sell a product, but I have talked specifically, and I will put my reputation and name on the line to say I have talked to their engineers, and they have told me there is no reliable way that you can get a reading that's reliable between two insulated conductors. Now, what you could get is if the results plummet when you do conductor to conductor, that tells you that somewhere in there is damage to opposing insulated components at that location, which you might not get through a continuity test, because maybe it's crushed and you still have the nylon, if it's thermoplastic, that's separating. In other words, you don't have direct metal-to-metal contact. But when you put some voltage on it, and now you have this current, it's able to break down that potentially thin, damaged part. But that's okay. I encourage that. I don't have any problem with that aspect of it if you're just checking the integrity of it. Okay, because that will check the integrity of it, and that will give you a reading that will plummet. That's fine. But the general rule is, if I'm connecting insulated conductor to insulated conductor and I'm getting readings in the anywhere from the 2 to 99 mega ohm rating, I don't necessarily say that it's bad. It could be due to contaminants, different thing that's on the wire, the temperature, the humidity, how long it was installed. It could be the length, the distance. You know, I routinely get calls about 5 and 6 and 7 and 8,000 foot runs of wire. Okay, the longer it gets, the more potential current leakage, because you have more opportunity, more surface area to do so. However, if you don't provide a reliable path to take those readings, then the results are going to be kind of skewed. So what is the true shining light of a mega ohm meter when it comes to wire and cable? And let's talk about that. So if I have a metallic raceway, an EMT, rigid metal conduit, FMC that I might pull individual conductors in, something of the metallic type, then I have insulated conductors in there. If there's any voltage that applied on it and I have leakage current and I connect to the actual armor, then I can get some leakage current if it's going to be within the acceptable range or not, and then my meter will tell me based on those readings. Okay, it determines the amount of actual leakage current out, which helps translate into a result that we get on the meter. Now, that's a viable application, and the engineers will tell you that. So I have a metallic raceway that does that. Now, what about a metal clad cable? Well, a lot of people want to do these mega ohm tests on that, and if all the insulated conductors are in good shape, the readings can vary, because when you go from insulated conductor to insulated conductor, if I don't see something that totally plummets down into the very low kilo ohms, if I get anything in the mega ohm range, then I've got to first of all say, look, I'll investigate it, but that's not unheard of, because these are two insulated components, okay? And the old rule used to be, and it's not so followed much today, but it used to be 1 mega ohm per 1,000 volts applied. And that's what it used to do. So if we're not even applying 1,000 volts DC, if we're doing a 500 volt test, then it kind of gives you an idea that the actual readings can be pretty low and still be a pretty good wire. So insulated conductor to insulated conductor, unless you're looking for some signal that it's a total damaged wire, and I still encourage the test. But what I want to guard people against is the values that they get when they check an insulated conductor to an insulated conductor in a cable. Because if this talk MC cable, if I have an MC cable, I have the individual conductors, and based on UL 1569, you actually have a binder material that wraps the conductors, and it separates it between that and the armor. Now, with that said, that has what's called a polyester wrap, or it could be a mylar wrap, which because a mylar is a product of DuPont. Whatever the manufacturer chooses and meets the standards within UL 1569, they can use it, and they wrap it around these conductors. It's a binder. Now, we're still checking insulated conductor to insulated conductor. And of course, if there was a bare equipment grounded conductor in there, then you might be able to get some reading because it has intimate contact with the conductors in there, or provides that return path for you to hook the meter to one conductor and then one to the equipment ground. Reality is most of the MC is going to have an insulated equipment ground. Now, nothing in the code says that you can't have an insulated, cover, or bare based on 250.118. Now, there's other areas in the code that's going to demand an insulated equipment grounded conductor, most notably in 517.13b applications for healthcare facilities, and I get all that. But the reality is there is a binder between the insulated conductors, so connecting onto that cable armor does no good. You're not going to get any. Now, if you're suspect to the installation, in other words, all MC cable has a maintained minimum bending radius, means you can't bend it any tighter than what's basically given us in the code. And so if you notice that that is bent beyond its maintained minimum radius on any bend, then you potentially could damage the armor. And if you damage the armor inside, you could have caused the polymeric wrap or the polyester tape or the mylar wrapping to separate and expose those conductors. You might elongate the back end of those insulated conductors, thus breaking down or thinning out the insulation. And at that point, you create a weak point, and that you might be able to test something onto the armor if you have suspect that the cable has actually been bent beyond its listing. Okay, or beyond what's supposed to in the National Electrical Code. Okay, if that's the case, that's a good reason to do some testing. All right, so you got to understand what the testing is there to do. But just to take two insulated conductors, whether it's tray cable, MC cable, individual conductors that are pulled in a PVC raceway, when you're measuring insulated conductor to insulated conductor, you're only looking for a total damage. Okay, you're looking for something that continuity wouldn't pick up because maybe it's damaged, but not all the way down to the conductive material. Yet the insulation is damaged, so it's just a quick test. But if you do those tests and you're getting mega ohm readings in your test results, whether they're 2 mega ohms or trigger ohms or tera ohms, what did I say, trigger? Tera ohms, whatever you're trying to read. Usually it's going to be in the giga ohm ratings. You really have to just take that for a grain of salt. Okay, so keep that in mind. That's kind of what we're talking about with testing. And I'm just trying to give you a little down and dirty on those type of things, because for years as an electrician, I've read manual after manual that says check A to B, B to C, A to C, each individual conductor to ground, the equipment ground, and look for those readings. And the reality is no reading is near the same. Now you might have the same product, the same cable, the same individual conductor produced at the same day. It's the same reel. You take the same lengths, you put it in raceways, you're going to get different results. All right. Yet these conductors have measured the insulation resistance at the factory, and it's acceptable. But then you get it out and you install it, and you get these varying readings. And you have to understand that the values that you're going to get in our facility or any of our manufacturers' facilities are nowhere near the values that you're going to get. Now, some people might say, well, they should be. That is literally impossible, because we actually dunk it in the water at a controlled temperature, and we actually test the thermoset through it. And then when it comes to the thermoplastic, we're actually imposing a large amount of voltage directly onto the conductor as it's moving down the line. And again, we're talking anywhere between 7,500 volts and 20,000 volts, depending on the conductor size and insulation thicknesses and what have you. We're directly testing this product before it even gets put on the reel. Now, the other question people ask me, because I'm trying to answer all these questions, and I did get some emails about it when I kind of put out there that I was going to do a teaser about this. And we are doing a video on this too, to do some, to show some things. But when you're doing it out in the field, can you dunk test both thermoplastic and thermoset? And the reality is, yes, you can. Most of the thermoplastic is going to be THHN/THWN-2. It's rated for wet location. The time period that you're going to be exposing it to is a very short amount of time. As long as you don't get the ends down below the water, then they're acceptably done. So could you set up your own dunk tank on your job site if you want to double check all your reels prior to putting them in the water, prior to putting them in the installation? You can do that. Just remember that in reality, you're going to probably do more of your testing in a dry environment. That means you're going to put them in a raceway. And you have to understand that unless it's a metallic raceway, the values that you get are going to be skewed up and down. In fact, I spoke with a leading manufacturer of, and I won't say which of those 3 brands that I said, and they basically said that it is impossible, that that's not what the product was designed to do. Now, it's designed to check the insulation in motors and the windings and transformers and other electrical components that somewhere in there, you have a lot of really thin film or separation between parts that are grounded and not. And it's testing the validity of all those applications. But when we're talking about wire and cable, it is very tough to do. Now, again, can I get some reliable readings if I have a metallic outer conduit? Yes. If the conductors inside are all insulated, yeah, I can get some readings. And if there is any leakage current, we'll have a return path for that. But in non-metallic products, it's virtually impossible to do that. Okay, especially if you have no bare equipment grounding conductor in there. The next thing I want to talk about is that I have, in the last couple weeks, have gotten a lot of calls. In fact, I got a call from a competitor of ours asking me to help them out with an issue. And, and again, most people know me. That doesn't matter who I work for. I can help you out anonymously because I just like to help. And the question was, and we've run into it, where people are testing their wire, and they're taking a reel of wire, and they're trying to test this wire by connecting one end of the mega ohm meter to the wire conductor, and then the other end they're taking to a ground rod or some grounding component like a grid or let's just say for simplicity, a ground rod in the ground. Okay. And they come back with the results, and there's some testing standards that talk about doing that. And my response to that is, how in earth, and that's kind of funny I'd say that, how in the world could you ever get reliable results? These meters are designed to take a voltage, 500 volts DC or 1,000 volts DC. Again, we're not talking about high pot testing. And what it's doing is it's actually taking this voltage, which is pressure, and putting it out, inducing a current inside the conductor, and then it's testing the insulation's reliability of this insulation. And it's trying to get a reading back on this meter because it has 2 probes, right? So if I'm connecting one of them to earth and I've got this isolated conductor, knowing that the earth is a very high point of resistance. In fact, the National Electrical Code tells you that it can't be used as a return current path. The resistance is way too high, okay? So how in the world could I check? And I know people have done this, and I've seen it, and I can even show you documents where they say do this. Connect the one end of the conductor and the other end to ground out in the earth and take the readings and look at it. And people want to know why their readings are sporadic. And then sometimes they get a reading that looks acceptable, and they go, wow, look, it works. And I'm like, yeah, it doesn't really matter to me what reading you're getting on that device. The real fact is, you're connecting to a conductor that is isolated from ground, and then you're expecting some kind of return path through ground. Your machine is going to come up with some kind of reading, but it's going to be an inconsistent reading to use because there is no viable return path. Now, you can say to me that you've done this for 30 years, and you can say, well, Paul, nobody I know would ever do it like that. I have emails. I have documents. So you don't have to believe me. You can call me a whack nut if you want. That's fine. I've been called worse, especially by my own electrical community. But in reality is, you cannot get any reliable results. And there are people out there doing the testing, taking the money, saying that you can, and that is incorrect. It is not reliable. So that brings me to the 2 to 99 mega ohm rule. From 2 mega ohms to 99 mega ohms, the wire and the cable is probably acceptable. You have to look at it and see what are the conditions. So when somebody calls me and says, Paul, I got a reading between 2 and 99, say it's 50 mega ohms. All right, my response to them is, all right, well, if you're testing to a NETA standard, which is one standard for testing, they have two different types of testing, and one is acceptance testing and one is the maintenance testing. Maintenance is a issue where we're going to assume that you have kept records every 6 months or every year, and you're just comparing your results to that, okay? In a perfect test environment where we have a metallic raceway or we know that we can test conductors, not insulation to insulated conductor, okay? That's a problem. But it's an ongoing test procedure that you keep records of. Now, the acceptance is, what is the minimum level of acceptance for the installation in a new installation? And the NETA standard says 100 mega ohms is the minimum standard. Now that, most of the time, our testing, I can promise you, in the lab or in our facility, are way above that. I mean, we're generally in the giga ohms. Okay, now it depends on the length, because the longer it gets, you're going to have more surface area, and there's notably going to be more leakage current because of the greater amount of surface area. That's all taken into account in the UL standards. So we adhere to those standards. Okay, so when you're testing it out in the field, though, and you're using something like the NETA standard, you have to understand that the NETA standard doesn't tell you how to do the test. It doesn't say you test A to B, B to C, C to A, each to ground. Doesn't get into that. The manufacturers of the devices will tell you how to do that. And a good example of that is in the Flukes Stitch in Time document. It shows a picture of the connection to the insulation of a conductor and then to the other lead to the conductor. That is totally incorrect, and the engineers told me that was an error in publication. It's supposed to be some kind of armor or lead sheathing or something on there that you're making a connection to, and then you connect to the inner conductor. You cannot clamp a probe on the actual insulated conductor and expect to get any reading. You can't read a single conductor by one clipping onto the copper or aluminum and the other onto the thermoplastic or thermoset insulation. It doesn't work like that. Trust me. All right, so that was an error, and that misled a lot of people. But the rest of the stuff in their document is very accurate, and so we can discount that and say, look, it does show every testing of wire or cable beyond that by using something with a lead sheath, which is a little outdated today because we don't really see that. But at any rate, it does give you some examples of doing that. The other use for a mega ohm meter is when you do a medium voltage, that is a viable test. Or if you're doing coaxial cable, that's a viable test. Or you're doing any shielded type of cable that has a foil shield on it, individual conductors or twisted pairs. Okay, because you're testing the conductor and you're testing the foil or the armor around it to see if it can detect any excessive, unacceptable levels of current leakage through insulation that might have been stressed out during the test. Okay, that's a viable test. So I'm not here to say that the meters are not usable or are not beneficial, but I'm really doing this in all fairness to the manufacturers of these products. The expectation of what their products can test for sometimes gets construed differently through the industry. And people just immediately say, did you test this? Did you test this? Did you fluke it? You know, all these type of things. And the reality is we're not doing the manufacturers of those products a real justice because those products have a specific test need. I've used them in my career for motors, testing windings, a lot of things like that to test the reliability of the insulation over time if it's deteriorated, or older type of equipment or motors, and very viable need. If I've got cables that have that intimate contact with some type of armor with the insulated conductor, then I have a viable test product here. So really just trying to dispel the myths here, because I routinely get people testing insulated conductor to insulated conductor and they're trying to interpret these results, and I'm like, really, it's not really what you should be doing. So I have no problem coming to a job site and explaining to somebody how to actually do a test, but I can tell you up front, if you're calling me and it's a PVC raceway and you've got all insulated conductors in it and you want to test insulated conductor to insulated conductor, I'll say, okay, you can do that, but ignore your mega ohm readings unless it drops below 2 mega ohms, because then you're just looking for total potential breach failure. And I'll also ask you if you've done a continuity test, because it might be you don't get continuity, then you test it, and then you notice that two conductors are really plummet, really low. Then it tells me that maybe you have some kind of installation damage. But I can promise you those conductors were pre-tested back at the facility, so something had to happen in that installation. Not going to say that it's impossible, but look, most of us manufacturers have visits by UL or other third-party testing like ETL or whatever come to the facility on a regular basis. They look at our machines, they check the process, we send away samples, we do testing. The machines test the sparkers routinely, and maintenance tests it. Look, this is our livelihood. This is the manufacturer's business. We don't put something on a reel and send it out that did not pass a dunk test or the spark test. It's just that simple. It's not a good business for us to do it otherwise. We sell way too much wire. There's way too much on the line when you install it in buildings to not test the product. And you have to understand that in the field, the testing is dramatically different. You have air involved. You have contaminants involved. You have conditions of use involved. You have temperatures involved. You have contamination, dirt, dust. You have pulling lubricants. You have terminations. You might be testing after you've already terminated. That's not the right thing to do. You're trying to test it on the back of a truck and you're actually taking one of the leads to ground. You're doing all these tests that you've been told to do, but do they really mean what they're supposed to be doing? Do you really understand the difference? So I just wanted to throw that out there to everybody. Hopefully I've explained a little bit more to you about the testing and the condition, and I like to say it has to be what I call the perfect storm, the perfect test condition in order to be able to test a cable. So as a summary, tray cable that's all non-metallic in all insulated conductors, even the equipment ground is insulated. Nearly impossible to do any type of test on it unless it's foil wrapped, unless it has some kind of aluminum type or foil around in intimate contact with the conductors. Okay, if it's one side is a polymeric material and the other side is foiled, then it's not going to, that foiling, that metallic component needs to be in contact with the insulated conductors to get any value. So you can't really get any values except for the insulated conductor to insulated conductor test that looking for something that's going to plummet. And that's kind of a go, no-go type of test. Not the same as a high pot, but we kind of term that as a no-go. In other words, if it really, really plummets, then you know something's wrong, because theoretically between two insulated conductors we should have a relatively high level of insulation resistance, okay, unless something's been damaged during the installation. All right, so, and again, it doesn't take much to damage insulation. I have got pictures. I've been on job sites where guys are walking across wires, stepping on cables. Yeah, we make them as robust as possible, but can they be damaged? Yes. And you have to take care. You're going to put them in the wall. You're going to put them in an installation where they're not going to be damaged. Don't take the risk of damaging during that process. You have to treat them with care. You're very responsible for that. Don't blame the manufacturer who's produced the product, tested the product, heat shrunk the product, put it on a truck, sent it to you. You've examined it. That is your baby now. Okay? All right. So anyway, that's kind of the things to remember. So if you have any additional questions on that, I am more than happy to answer your questions on wiring cable, the National Electrical Code, anything that you might want to know about the testing process, what we do, the processes. And as a reference, I'll tell you, we test all of our thermoplastic in accordance with UL 83. All of our thermoset products, we test all in accordance with UL 44. The test procedures that we conduct these under are all documented in UL 2556. So all of this is published information that the manufacturer has to meet. Once it gets out in the field, we highly recommend the NETA standard. And again, that standard is going to say that the acceptance test is going to be 100 mega ohms or more for the installation. And you got to remember, those values are based on a properly done test, not on tests that are going to allow for fluctuated values because you have no real return path during the test process. Insulated conductor to insulated conductor is not an adequate return path in order to get any reliable readings, except for where you might have two damaged conductors and their opposing damage is right near each other, and that insulation has been crushed, and now you might be able to get something because of that damaged area, and that's really all it's good for in that type of application. Okay, so keep those things in mind. If you have any questions, remember you can always email us at info@masterthenec.com. You can go to our Facebook page and post a question, post a response. You can follow us on Twitter at masterthenec. All of these avenues allow you to Ask your questions. We have a message board. If you go to masterthenec.com, you click on the message board link and you can go there, join up, get an account, ask your question. You will never get belittled. You'll always get an answer. Somebody asked me, is that a moderated board or is it open to anything? No, it is very much moderated. If you go in there and you start crap, or if you go in there and you start lies, then you're going to be removed. That's simple. This is not a democracy. I own the board. Okay, so people say, am I only going to post information that's beneficial? Yeah, I'm going to. Am I only going to post my opinion? No, that is not going to happen. If you have an opinion, you're free to post it. But if you get into a bashing mode and you start posting negative stuff that's incorrect or not substantiated, I have substantiated my information here. You are free to call Fluke. You're free to call Megger. You're free to call Hioki. Ask for their engineering department. Refer to this radio show and ask them point blank, is their products, their Megometer, designed to be reliable for testing insulation resistance between two insulated conductors, and see what you get. Okay? Anyway, thanks for listening. Hopefully it helped you out on something and gave you a little more insight into it. God bless, and hopefully join us next time here on Master the NEC.